Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video, these 5.2 Algebra 2 notes. So today, essential question, how do I factor quadratics? All right, we were just looking at graphing quadratics in the last one, and now we're looking at how do we factor them. All right, so here we go. Monomials, binomials, and trinomials. A monomial is a polynomial with one term. All right, a binomial has two terms. All right, and yes, you got it right, has three terms. All right, so we're going to look at factoring all these throughout the chapter here. So the first one, monomial, an example, might be just remember these terms are things that are separated by addition signs. So a monomial doesn't have any addition signs. Let's just say it's 3x squared. Okay, one term could be 7, could be 3x, doesn't matter. All right, a binomial has two terms. So let's say we have 3x squared, that's one term, plus 7x. Okay, that's another term, so it's binomial. So a trinomial has three of them. So let's say it's 3x squared plus 7x, and let's add on a 2. Okay, that is three terms. Okay, so today we're looking at factoring. So we're writing a trinomial as a product of two binomials today. That's what factoring is. So what we're doing is we're bringing this ax squared, this standard form that we talked about last time, and we're bringing it into kind of that intercept form, which we looked at as well. Okay, so here's a big thing, FOIL. You guys have done that before in Algebra 1, different courses leading up to this. We're going to talk about FOIL and how we can use that to check our answers today. All right, so what we're looking for mainly today is we're looking at two numbers, okay, that when they're added together, they give us the middle term b, and when they're multiplied together, they give our last term c. Okay, so that's kind of what we've been talking about is this diamond. Okay, so we have to find two numbers that multiply to give us c and add to give us b on that bottom. Okay, so that's what we're going to fill in today. So we have to find some numbers that go in here to do that for us. All right, so here we go. Let's look at this first one. We're going to factor this x squared minus 3x minus 18. So here I can find my a, b, and my c. Okay, and the way that we do this is we literally just toss it right into that diamond. So I have that diamond, I put my c on the top and my b on the bottom, negative 3. So now I have to find two numbers that multiply to negative 18 and add to negative 3. All right, so I know that since this number is negative, that the bottom one, that the bigger number has to be negative, the absolute value of the bigger number. So I look here and I know that negative 6 and positive 3 multiply to give me negative 18 and add to give me negative 3. So the only thing that I do here is I set up myself two binomials, okay, and I go x and I go x, and then I just put them in. So I go minus 6 plus 3. Okay, and that is done. All right, that is factored. That's all I had to do there. Pretty quick. So now you can always check yourself by FOIL. So check by FOIL. All right, so now I can go x times x is x squared. Okay, outside is x times 3, gives me plus 3x. Inside gives me negative 6x. And this guy gives me negative 6 times 3, gives me negative 18. So I look here, if I combine like terms, I go x squared. This combines to make negative 3x minus 18. All right, so you notice here that these two guys are the exact same. So you can always check yourself by FOIL here. Always, always, always can check yourself. All right, let's do this last one of this example. Here we go, right away, my A, B, and my C. I know that my C goes on top, that goes negative 12, and I have to add to find 1. So here, my bigger number has to be positive. So I know that 4 and negative 3 give me negative 12, and they add to 1. So I go x plus 4 and x minus 3. All right, so that's good, great there. Again, you could check yourself by FOIL if you wanted to. All right, check yourself. Make sure you got it right. All right, so moving on here, we have to look at a different type, and this is factoring when our a value is actually greater than 1. Okay, so before, if you look at these two examples, my a was 1, my a was 1. So when my a is not 1, I have to do a little bit more work. And it talks it through pretty nice in these steps right here. Okay, but I'm going to look at them through this example. All right, so for this first one, I have to factor and notice that my a is not 1, so I'm going to have to do a little bit of different here. My first new different part is I'm going to multiply my a and my c. So now I have x squared plus 7x minus 18. Okay, that's my first part. Now notice here that my a value is sort of 1. At least now it is, right? So now I go through and I can put this guy right in the diamond. So I'm going to go negative 18 and 7. Two numbers that multiply to negative 18 add to 7 are going to be 9 and negative 2. So now this guy turns into x plus 9 and x minus 2. Okay, so this guy right here factored turns into this. Okay, but that's not what I was asked to do. I was asked to factor this one. All right, then the way that we bring this back is we're going to take our original a value and we're going to divide that by each of these numbers that we got. Okay, so now this becomes, and when I simplify this, it becomes x plus, and I'm going to erase this, and I'm going to go up here. This guy becomes, ooh, I did not mean to do that. All right, this guy becomes x plus, and if I simplify 9 over 6, that turns into 3 over 2. And if I simplify 2 over 6, that's going to be x minus 1 over 3. Okay, and the cool part in how this works is that when we simplify these guys, this denominator goes back out in front of my x. Okay, so my final answer here is going to be 2x plus 3 and 3x minus 1. Okay, so a couple different parts there, and that's why when our a is greater than 1, it makes it a little bit tougher. Okay, so let's look at another example of this in number 4. So if I scroll down here, if you guys go to page 68, it says number 4. This guy, it has an a value, again, that is greater than 1. I go a, b, and c, so I multiply my a and my c. So I get x squared plus 7x plus 6. Put this guy into the diamond. So here I'm going to have, and this guy turns into 6 and 7. So I know that 6 times 1 gives me 6, adds to 7. So this is going to be x plus 6 and x plus 1. All right, so here I go through and I remember that, hey, my a value is not 1, so I have to divide this guy by 2. So I divide him by 2, and this guy just turns into simply x plus 3. 6 over 2 turns into 3. And this guy, 1 over 2 does not simplify, so that 2 goes out in front. So this becomes 2x plus 1. All right, so if you don't believe me, what do you do to check? You can always FOIL. All right, so if we FOIL this guy back into each other, we get 2x squared. All right, we get 1x. We get 6x, and we get 3. All right, so if this guy simplifies, I get 2x squared plus 7x plus 3. That's exactly what we started out with. All right, so example number 5, I'm going to let you guys try example number 5 on your own. All right, I'm just going to kind of go through these special patterns here. Okay, so these special patterns, there's 3 of them. They're pretty nice, but here's the thing is that you don't actually need to use them. Okay, so if you don't see them right away, you can actually just go through here. This guy's your A, and your B is actually missing here, so this would be actually the same as 4x squared plus 0x minus 49. Okay, so then that would be your B. So you can actually just go through and put it in that diamond. But here, the difference of 2 squares pattern says, hey, these guys are both perfect squares. And if you notice that, that's great. And they actually just go right into this little equation right here, which is super cool. So here, I know that 2x, and if I square that, it gives me 4x squared. All right, minus, and I know that the square root of 49 is 7. Okay, so this is kind of my A and this is my B now in this equation up here. So now I can just plug these guys in. So I get 2x plus 7 and 2x minus 7 is what this guy factors into. So again, if you notice that pattern, that's great, but if you don't, that's okay too. All right, these perfect squares are also kind of nice because you see that these last numbers are perfect squares. So like this b is a perfect squared term here. So I noticed that the square root of 36 is 6, okay, and it's nice, and when this is nice is when you have 6 times 2 in this middle term, okay, so that's your 2ab here, okay, and the nice thing about this is if you notice that, you can just call this one as x plus 6 squared, okay, which is the same as x plus 6 times x plus 6. All right, so again, if you FOIL this guy out, you can see here that, hey, this guy turns into x squared. We got two 6x's in here, so I have 6x plus 6x plus 36, and then these guys combine to make that 12. All right, so kind of a nice little easy thing there. Perfect square trinomial now. So if it's a trinomial of subtraction, so notice here that this one's negative. Again, the square root of 25 is a nice number. That's 5. So a lot of times this works into, and it's not plus anymore. It's actually going to be x minus 5 squared. Okay, again, if you notice that, that's great. But again, those diamonds are going to help you out there too. Awesome. So thank you for listening to Mr. Laxton's video on these 5.2a notes, and good luck.